You did everything right. You researched sustainable building, you invested in passive design, you hired a contractor who sold you on the most natural, most elegant HVAC solution available, buried earth tubes that use the stable temperature of the ground itself to precondition your incoming fresh air. No refrigerants, no compressors, just the earth doing what the earth has done for billions of years. And that system is going to cost you everything. Right now, buried beneath your carefully landscaped yard, inside those HDPE or concrete pipes that your contractor promised would last a lifetime, a biological ecosystem is establishing itself. Mold, bacteria, and condensate are colonizing the interior surfaces of your earth tube system, and every breath of fresh air you are pulling through those tubes, every cubic foot of air entering your home, is being filtered through a subsurface mold colony before it reaches your lungs and the lungs of your family. I am Engineer Vance, licensed forensic structural engineer and building science specialist. I have investigated earth tube system failures from Vermont to Arizona, and I am here to tell you that the geothermal earth tube concept, as it is being sold and installed in residential construction across the United States today, represents one of the most dangerous intersections of good intentions and inadequate engineering I have encountered in over 2 decades of forensic practice. Stay with me. What I am about to show you is not theoretical. It is happening right now, beneath thousands of American homes. Let me establish the engineering premise, because the concept behind earth tubes is genuinely elegant, and the physics that supports it is completely real. At a depth of 4 to 8 feet below the ground surface in most continental U.S. locations, soil temperature stabilizes at a relatively constant value, typically between 50 and 60 degrees Fahrenheit year-round, depending on your geographic latitude and local soil thermal properties. This phenomenon is called the soil thermal flywheel effect, and it is the same principle that made root cellars effective food storage for centuries before mechanical refrigeration existed. An earth tube system, also called an earth-air heat exchanger or EAHE, exploits this temperature stability by routing incoming fresh air through buried pipes before it enters the building. In summer, 100-degree outdoor air passes through pipes surrounded by 55-degree soil and arrives at the building significantly cooler, reducing the cooling load on the mechanical system. In winter, 10-degree outdoor air passes through those same pipes and arrives pre-warmed, reducing heating demand. The theoretical energy savings are real, documented in peer-reviewed literature, and the concept has been implemented successfully in commercial and institutional buildings with proper engineering. The problem is not the physics. The problem is the condensation management, the biological contamination risk, and the near-complete absence of code-required design standards for residential earth tube systems in the United States. And that gap between elegant theory and contaminated reality is costing homeowners tens of thousands of dollars in remediation and creating indoor air quality crises that their doctors cannot diagnose because nobody told them what was buried under their yard. Here's where the engineering breaks down, and I want you to understand this at a level of technical depth that will permanently change how you evaluate any earth tube proposal. The failure mechanism is condensation, and it is not a design flaw that can be engineered away with better pipes or better installation. It is a thermodynamic inevitability under the operating conditions that earth tube systems create. When warm, humid outdoor air enters a buried pipe whose walls are significantly cooler than the air's dew point temperature, water vapor in that air condenses onto the pipe walls. This is identical to the condensation that forms on a cold glass of water on a humid summer day. The dew point of typical summer air in the eastern United States, where relative humidity routinely exceeds 70%, is between 60 and 70 degrees Fahrenheit. The pipe wall temperature in a properly installed earth tube system is approximately 55 degrees Fahrenheit. Every single cubic foot of summer air flowing through that system is depositing liquid water on the interior pipe surfaces. Every single breath of air your family pulls from that system during summer operation has passed through a wet, dark, organically contaminated underground environment before it reaches your living room. The critical engineering quantity here is the latent heat load, the energy contained in the water vapor component of humid air. ASHRAE Fundamentals Handbook. Chapter 1 defines this clearly, and any mechanical engineer performing a proper earth tube design must calculate the condensate generation rate for the peak summer design conditions in your specific climate zone. For a typical residential earth tube system moving 300 cubic feet per minute of summer air at 90 degrees Fahrenheit and 70% relative humidity through a pipe maintained at 55 degrees, the condensate generation rate is approximately 1 to 2 gallons of liquid water per hour deposited on the interior pipe surfaces. That water has to go somewhere. In a properly designed system, it drains to a sump with positive drainage. In the vast majority of residential installations I have investigated, it pools at pipe low points, accumulates at joints, and creates standing water conditions inside a dark, oxygen-limited, nutrient-present underground environment. That is not a passive cooling system. That is a perfect biological incubator buried 6 feet under your backyard. The biological consequence is biofilm formation, a consortium of mold species, bacteria, and other microorganisms that establishes itself on the moist interior pipe surfaces within weeks to months of system operation. The mold species most commonly documented in earth tube biofilm include Cladosporium, Penicillium, Aspergillus, and in high moisture conditions, Stachybotrys chartarum, the species colloquially known as black mold. Every cubic foot of air moving through a biofilm-contaminated earth tube is being inoculated with mold spores before it enters your home. The concentration of mold spores in earth tube discharge air has been documented in European research, where earth tubes have been more widely studied, at levels between 100 and 1,000 colony-forming units per cubic meter, compared to typical outdoor background levels of 10 to 100 CFU per cubic meter. You are not bringing fresh air into your home. You are bringing contaminated air into your home through a biologically active underground pipe that nobody can see, nobody is inspecting, and nobody is cleaning. Now here is the code dimension that should alarm every building official and every homeowner equally. The International Residential Code and the International Mechanical Code contain no specific design requirements for residential earth tube systems. There is no pipe material specification, no minimum slope requirement for condensate drainage, no access or inspection provision requirement, no filter or UV treatment mandate, no biofilm monitoring protocol. Earth tubes are being installed in American homes under a complete regulatory vacuum, and the contractors installing them are operating without any code-mandated design accountability whatsoever. ASHRAE Standard 62.2, which governs residential ventilation and indoor air quality, requires that mechanical ventilation systems deliver outdoor air that is free of biological contamination. An earth tube system discharging biofilm-laden air into a home's ventilation stream is a direct violation of the intent of ASHRAE 62.2, but because earth tubes are not specifically addressed, enforcement is essentially impossible, and homeowners have no regulatory protection. Let me walk you through a forensic investigation I conducted in the Asheville, North Carolina area in 2022, because this case illustrates every failure mode I have described with a precision and a human cost that every homeowner considering an earth tube system needs to hear. The clients had built a custom passive house in 2019, a 2,200 square foot net zero energy home with an earth tube system consisting of 4 parallel HDPE pipes, each 8 inches in diameter and 60 feet in length, buried at a depth of 6 feet below grade. The system was designed to provide approximately 250 cubic feet per minute of preconditioned fresh air to the home's energy recovery ventilator. The contractor had represented the system as a low-maintenance, long-life passive ventilation enhancement that would reduce the home's HVAC loads by an estimated 20 to 30%. By the summer of 2020, the homeowners noticed a persistent musty odor in the home that intensified whenever the ventilation system was operating. By fall of 2020, the wife, a non-smoker with no prior respiratory history, had developed chronic sinus inflammation and a persistent cough that her physician initially attributed to seasonal allergies. By early 2021, their 8-year-old daughter had developed asthma symptoms that required prescription management. They contacted me in spring of 2022 after their family physician, suspecting environmental exposure, recommended a forensic indoor air quality investigation. My investigation protocol included borescope inspection of all 4 earth tubes, air sampling at the earth tube discharge manifold, indoor air quality sampling at multiple locations throughout the home, and condensate drainage assessment at the pipe low points. The borescope inspection of all 4 pipes revealed extensive biofilm development across the interior surfaces, beginning approximately 12 feet from the intake end and continuing through the full remaining length of each pipe. The biofilm was heaviest at the pipe joints, where the HDPE couplings created slight interior diameter changes that accumulated condensate and debris, and at the pipe low points where standing water had established permanent moisture conditions. Air sampling at the earth tube discharge manifold measured mold spore concentrations of approximately 800 colony-forming units per cubic meter, with Cladosporium and Penicillium as the dominant species. Indoor air samples in the main living area measured approximately 400 CFU per cubic meter, 4 to 8 times the typical outdoor background level for the Asheville area at the time of sampling. The condensate drainage assessment revealed that the contractor had installed the pipes at a nominal slope of 1/8 inch per foot toward the discharge end, less than half the minimum slope I recommend for condensate drainage in earth tube systems, which is 1/4 inch per foot at absolute minimum. As a result, standing water had accumulated at 3 low points in the system, 2 of which were completely inaccessible without full excavation. Remediation required complete earth tube decommissioning, physical disconnection of all 4 pipes from the ventilation system, and sealing of the intake and discharge ports at $6,200, mechanical ventilation system reconfiguration to direct outdoor air intake from a properly located above-grade intake point at $4,800, indoor mold remediation of the mechanical room and adjacent ductwork per IICRC S520 at $7,300, and a medical monitoring program for the family. Total remediation cost for the building systems alone, $18,300. The earth tube system that was supposed to save them money on energy costs had cost them $18,000 in remediation and 2 years of documented respiratory health impacts on a family that had done everything right. So if a contractor is proposing an earth tube system for your home, or if you already have one installed, here is what engineer Vance needs you to verify before another heating and cooling season passes. The first question is whether the design includes a condensate drainage system with positive slope to a sump or daylight drain at a minimum of 1/4 inch per foot throughout the entire pipe run. If the contractor cannot show you a grading plan and a drainage endpoint for the condensate, the system will accumulate standing water, and you will have a mold incubator buried under your yard within the first summer of operation. The second question is whether the system includes access ports at regular intervals for borescope inspection and physical cleaning. A properly designed earth tube system requires inspection and cleaning every 2 to 3 years at minimum. If the pipes are buried with no access provisions, the system is not maintainable, and an unmaintainable earth tube system buried beneath your foundation landscaping is not a passive asset. It is an active liability, accumulating biological contamination with every hour of operation. The third question is whether the system includes a pre-filtration assembly at the intake to prevent insect, debris, and particulate entry into the pipe, combined with a post-tube HEPA filtration and UVC germicidal irradiation system before the air enters the building envelope. These are not optional upgrades. They are minimum requirements for any earth tube system that is not intended to serve as a bioaerosol delivery mechanism for your family's respiratory system. The fourth question is what the contractor's condensate generation rate calculation shows for your specific climate zone's peak summer design conditions. If the contractor cannot produce a psychrometric calculation showing the expected condensate generation rate in gallons per hour under your local design conditions, they have not engineered the system. They have buried some pipe and called it passive cooling. And the difference between those two things is the difference between a healthy home and an $18,000 remediation. If you already have an earth tube system installed and you are experiencing musty odors, unexplained respiratory symptoms, or elevated indoor mold counts, your first immediate action is an indoor air quality assessment with source-specific sampling by a certified industrial hygienist. Simultaneous air samples at the earth tube discharge point and at multiple interior locations will definitively establish whether the earth tube system is the contamination source. The cost of a comprehensive IH assessment runs between $1,500 and $3,500, and that documentation is essential if you intend to pursue a contractor liability claim. Your second action is a borescope inspection of the full pipe run to document interior condition, biofilm development, standing water locations, and as-installed slope conditions. Budget $800 to $2,500 for that inspection. And if contamination is confirmed, your third action is system decommissioning, physically disconnecting the earth tube system from the building's ventilation stream and sealing the intake and discharge connections. The pipes can remain in the ground. Excavation is rarely necessary, but the system must be completely isolated from any air path to the building interior before another season of contaminated air is delivered to your living space. For homeowners in humid climate zones, ASHRAE Climate Zones 1 through 4A, covering the entire southeastern United States, the Mid-Atlantic, and the Ohio Valley, my professional recommendation as engineer Vance is unambiguous. Earth tube systems carry a high risk of condensation and biological contamination in these zones that is genuinely difficult to manage adequately in residential applications. The energy savings potential does not justify the indoor air quality risk and the remediation liability. Better alternatives include ground source heat pump systems that transfer heat through a closed fluid loop rather than moving outdoor air through underground pipes, and high-efficiency energy recovery ventilators paired with properly filtered above-grade intake assemblies that deliver genuinely clean outdoor air without a biologically active underground passage in between. The earth tube concept comes from a place of genuine environmental intelligence. The physics is real. But the gap between the theoretical performance of a properly engineered earth tube system and the biological reality of how these systems actually perform in humid American climates, installed by contractors without mandatory design standards, without condensate management, without access provisions, and without biological contamination monitoring, is a gap measured in mold colonies, in respiratory diagnoses, and in five-figure remediation bills. Before you bury any pipe beneath your home in the name of passive cooling, demand psychrometric calculations, demand a condensate drainage plan, demand access ports, and demand UV treatment on the discharge side. And if any contractor tells you those requirements are unnecessary, walk away. What they are selling you is not passive cooling. It is a mold delivery system with a green marketing wrapper. I am Engineer Vance. Protect your structure. Protect your investment.